Now, through the wonder of Skype, I believe we're going to have our next speaker, one of my favorite people who talks about climate change, because she does it with heart and with humor. In fact, she has excellent comic timing. Dr. Katharine Hayhoe, who is joining us from Lubbock, Texas. And is she on the line? Do we have her? Hey, good to see you.
I am here, yes.
It's so great. What I love about her is she can speak to people. You're educating a whole generation of people on how to talk about climate change. I've seen you at the CCL conference several times. And so she is an atmospheric scientist whose research focuses on understanding what climate change means for people and the places where we live. She's professor at Tennessee Tech University and has been named one of Time's 100 most influential people. And another wonderful thing about her is when you mention her in a tweet, she likes that tweet. So thanks for your amazing tweeting abilities. Please welcome Dr. Katharine Hayhoe.
Thank you so much. It is great to be able to be here with you today. And thank you for that introduction. I do love Twitter and social media because it helps us connect with people and talk about things that are happening in real life, like the hurricane today. So let me share my screen with you here, just a second. All right. Why do we need to care about climate change today? The answer is staring us in the face. But let's start with the background, because we don't have hurricanes every day. We don't have heat waves or droughts or floods every day. So what is it that we need to remember long term? Wherever we live, we're already at risk from natural climate and weather disasters. That's just part of life on this planet. As long as there's been people who have fields and homes and things to lose, we have been affected by natural disasters. In the United States, some states are much more vulnerable to really costly disasters than others. Texas is actually number one. Since 1980, we've had 105 disasters that have caused more than $1 billion worth of damage. Florida, though, has a hefty 54 events, and of course, that is not including Hurricane Michael. So that's why there's a +4 on the map. When we look at this in terms of how much this costs per person, it looks slightly different. Florida is one of the states that has experienced the most costly impacts per person. Since 1980, per million residents, $10 to $20 billion. So we're talking a lot of money. We know that these events have a very large price tag, whether we're looking at hurricanes or droughts or heat waves that affect agriculture. All you have to do is peruse the headlines. Headlines from a couple of years ago, headlines from 17 hours ago. They tell us why these disasters matter, because they affect us. So wherever we live, we are at risk from what used to be entirely natural disasters, but today are becoming disasters that have been amplified or enhanced by a changing climate. Why is it that we care about a changing climate? It's because our disaster risk is already on the rise. It's on the rise because, first of all, our exposure is going up. What's our exposure? That's the number of people and the amount of valuable infrastructure and other goods that are exposed to a disaster. So we know that the more people there are in the world, the more people there are to be exposed, especially when people live along coastlines that are vulnerable to rising sea level and storms. We also know that there's more infrastructure in the world. This is just how many trillions of dollars of infrastructure there is. Look at the United States. It's at about $37 trillion of infrastructure. And most of that infrastructure cannot be picked up and moved when disaster threatens. We also know that it isn't just a matter of exposure increasing. Our vulnerability is also on the rise. How is our vulnerability rising? Because we're becoming increasingly unprepared for much of what we're seeing. This past year, the American Society of Civil Engineers issued their annual report card, and this was the headline: America's infrastructure is falling apart. It is desperately in need of $4.5 trillion investment by 2025. They graded the infrastructure, and as you can see, only one thing got a B. Everything else was C's and D's. So our disaster risk is increasing without climate change. It's just increasing as a result of more people, more infrastructure, more things at risk, and the fact that those things are becoming increasingly unprepared for a changing climate. But then we have the third part, and that is the weather and the climate events. We know, unfortunately, that a changing climate is exacerbating many of these events. Why does climate change matter if we're already naturally vulnerable? It's because our planning operates like this. This is a picture of Lubbock, Texas. It is as flat as many parts of Florida. And some of our roads are so flat that you could be driving down the road, staying in your lane, looking in the rearview mirror. Why? Because where you were 30 seconds ago, a minute ago, 5 minutes ago even, is a perfect predictor of where you'll be in the future. And that is how our society plans. It's building codes, our long-term water plans, how we allocate energy and other resources, even the type of clothes we have in our closet. All of this is based on the idea that what our conditions have been like in the past is a good predictor of the future. And this is true when climate isn't changing. But if you're driving up this very road in West Texas, just before you get to the top of the map, there is a huge curve in the road. If you are driving up that road looking in your rearview mirror, you're going to run off the road. And in the same way, planning for the future based on the past is like driving down the road looking in the rearview mirror. It works great when the road is straight and climate is stable. But when there's a curve in the road, then we have to look not just to the past, we also have to look to the future to make sure that we're prepared for what's coming up ahead. So what is happening? The number one reason why we care about a changing climate isn't because of a 1 degree Celsius or 2 degree Fahrenheit change in global average temperature. There's probably a 2 degree difference between one side of the room you're in and the other. We care about it because what seems like a relatively small change is actually an enormous amount of extra heat, as David was pointing out. And that extra heat is weighting the dice against us, taking what used to be naturally occurring hazards and amplifying them, making some of them stronger, some of them more frequent, and some of them both. The best analogy I have for this is literally a pair of dice. Imagine that we always have a chance of rolling a double six. That's a Hurricane Michael, or a devastating drought, or a record-breaking flood. But what's happening decade after decade is climate change is sneaking in and changing another number on one of those dice to a 6. So all of a sudden, we're seeing more 6s turn up than should happen naturally. And then we see a 7 and we say, what's this? We've never even seen an event like this before. Climate change is weighting the dice against us. How is it doing so? It's doing so in many different ways. I just want to highlight 3 of them for you. The first one is the fact that heavy rainfall is becoming more intense and more frequent. Why? Because warmer air holds more water vapor. For every degree Celsius the world warms, it holds about 6 to 7% more water vapor. And evaporation also speeds up when it's warmer. So today, when a storm comes along, as they always do, there's more water vapor sitting up there in the air for that storm to sweep up and dump on us. And we see this happening across the United States. Since the 1950s, we have seen significant increases in heavy precipitation, primarily in the Northeast, then the Midwest, then the Southeast, which is where Florida is. This is what's already happened in the last 60 years. The second way that climate change is weighting the dice against us that I want to highlight for you is heat waves. Now, the good news is cold waves still happen and winter still exists, but cold waves are becoming less frequent as heat waves become more frequent. Now, here's the interesting thing. People often say, it's cold outside, or even, we broke a cold temperature record today. How could you say the planet is warming over climate timescales of 20 to 30 years or more? Well, interestingly, did you know that last year, we, across the entire United States, we broke 10,000 cold temperature records. Yeah, 10,000 cold temperature records were broken last year in the United States alone. How many hot temperature records were broken? Over 35,000. That's a ratio of 3.5 to 1. And when we look at this ratio, we see that it is changing. If climate were not changing, it should be 1 to 1, the same amount of cold, the same amount of hot records being broken. But for the 2000s, that that ratio was 2 to 1. And like I just said last year, it was 3.5 to 1. So that's another way that climate change is weighting the dice against us. What's the third way? I think we all know that. Hurricanes. Climate change is absolutely weighting the dice against us when it comes to hurricanes. The question to ask is not, did climate change affect this hurricane? The question to ask is, how could it not affect this hurricane? Because tropical cyclones, hurricanes, and typhoons, they call them different names depending on where they are in the world. These types of storms are unique in that they get their energy from warm ocean water. And over 93% of the extra heat being trapped inside the Earth's climate system, it's going into the ocean. That's right, when we use global air temperature as a measure of global warming, we're literally measuring the tip of the iceberg. 93% of the extra heat being trapped by the blanket we are wrapping around our planet is going into the ocean, where it fuels stronger storms. So what specifically is happening with hurricanes? A lot. First of all, there's a lot more rainfall associated with hurricanes. As I said, for every degree the world warms, there's a lot more water vapor for that storm to sweep up and dump on us, and hurricanes are very big storms. With Hurricane Harvey, it's estimated that as much as 40% of the rainfall that fell during Hurricane Harvey would not have fallen if the same storm had occurred 100 years ago. 40%, just think about that. Some places got 50 inches of rain. Imagine if they had only gotten 30 inches. That's a lot, but the damages would be much less. So that is the first and most obvious way that hurricanes are getting more damaging in a warmer world. Then we also know that sea level's rising. And hurricanes are also damaging because of their storm surges. The more sea level rises, the more water is available for those storms to push onshore. So our storm surges today are greater and more damaging than they would have been 50 or 100 years ago. We aren't seeing any more hurricanes. That's because the conditions that lead to hurricane formation, some of them are increasing and some of them are actually decreasing. The Arctic is warming faster than the rest of the planet, and that decreases the temperature difference, which causes shear. And so in the future, we actually, believe it or not, we might see less hurricanes because the conditions conducive to their formation might decrease in a warmer world. But the hurricanes we do see will be much stronger on average, and we are already seeing those trends today because they're being supercharged by a warmer ocean. Not only that, but we are also seeing, and this is based on historical data, we are seeing that our storms are intensifying faster, much faster than they used to, and we saw that with Michael. We're also seeing, ironically, that many of them are moving more slowly, and that was the case with Florence and with Harvey. So when they move more slowly, they sit over you for longer and they can dump more rain. These are three ways that climate change is supercharging the naturally occurring risks that we've already faced. So how can we cope with this? This is what everybody else will be talking about. We can cope with it by identifying the risks that we already face today. And I work with cities across the United States, like Chicago, like Washington, D.C., like Austin, Texas, to quantify the risks that we face. And then what can we do? We have two choices. And the choices are not either or. The choices are yes and yes. What are those choices? Number one, we have to prepare or plan to adapt for the risks we cannot avoid. And many places in Florida are already starting to do that, to harden their infrastructure against rising sea level, for example. But the second thing we have to do is we have to reduce our impact on the planet. And we can do that by transitioning as soon as we can away from coal and gas and oil, which we have been using to get our energy very successfully for hundreds of years, to new types of energy that do not produce heat-trapping gas emissions. Solar, energy, wind, tides, even nuclear, where it's safe. We need to wean ourselves off fossil fuels, and we need to prepare to adapt to the changes that we cannot avoid, because some of those changes are already here today. Climate change is not 100% reversible, but we absolutely can avoid the worst and most serious and dangerous impacts by acting now. So, what can we do when we're faced with really expensive costs? And if you want to know more about that, the Risky Business Report is an excellent summary of the economic costs of climate change in the United States. What we can do is we can, first of all, reduce our vulnerability. That's adaptation, that's building resilience. Then what else can we do? We can also reduce our impact on the weather and climate events that are being supercharged by a changing climate. Because the bottom line is this: when we come to this curve in the road, which we are all negotiating piled into one giant bus with our wheels already on the rumble strip, we want to plan for that curve in the road to ensure a safe future for us all. Thank you.
Thank you, Dr. Hayhoe.